Guys, how are we doing today? This is Rohan. I lead engineering over at Meter.io, and I'm just making this quick video to walk you through a couple of concepts of the Meter.io API. In this, if you haven't already, make sure you go through the documentation on Meter.io. We've got your getting started documentation for our web developers. We've got it for our Android developers. So in this tutorial, we are going to follow the application that we created for getting started with the web app. This is not going to be very SDK specific, so it's not necessarily only for aimed at web developers. This is just to explore some of the concepts of the Meter.io API and take it from there. Also, we'll be using a token server in this example. So in the React getting started application, I think we hard coded the access tokens for the users, and then we performed API requests, and we took it from there. But in this case, we'll actually use a backend to issue the tokens for our users, and we'll make a couple of modifications to add some little bit of interactivity into this application, as we'll see later in this video. So to start with, why do we need a token server, right? So any API request that you make to Meter.io requires authorization, and this is kind of the pattern that follows with um, pretty much any API that you would use, any cloud-hosted service. So you have to identify. There are multiple ways of identifying yourselves. Users can identify themselves as specific users. Application principals, as we call them, can identify themselves using something we call access keys, right? So access keys gives you a key and a secret, and using that you essentially sign every request you make to Meter.io. Now the difference between an access key and a user authorization is when you use an access key, the secret's actually never transmitted on the wire. You just use it to sign the request in such a way that you prove that you have access to the key. User authorization, on the other hand, is as long as the value matches, it matches. So similarly, user authorizations expire within 24 hours. You have to refresh to get a new token within 24 hours to continue usage of the platform. Access keys do not kind of follow that pattern. They are permanently there forever unless you go and manually delete them. As you can delete them here. So let's get started with a quick API call, right? One of the most primary API calls that you have is when a user tries to see who the system identifies them as, right? So the API endpoint happens to be api.meter.io/v1/user/me, and let's do again, and I get a 400 pad request saying that I require a context of type application, but such a context could not be resolved, which I guess makes sense because there is nothing in this request that tells Meter.io which application to look in, which user are we talking about. This is just a completely out of the wild request, right? So one of the things that we'll do is we'll head over to the users panel. The users panel is something that you can use to access your users, and here we have created two users, Mr. Peanut Butter and Bojack Horseman. And I don't know, the fans of Bojack Horseman might recognize these characters, but I think it's the trend to just throw in a bit of pop culture here and there. So that's something we have been trying of late. So anyway, so these are the access tokens, and you usually won't see a lot of these access tokens. I've been testing a couple of things using this application. That's why there are a lot of them. Usually it's one token per device that the user would have an application on, usually. The limit on access tokens is pretty high. For user tokens, it goes as high as like 300. You can get up to 300 tokens, but it's usually a good idea in terms of credential hygiene to not have these many tokens out there. So anyways, let's create a new access token for our user, Mr. Peanut Butter, and this is a header that you have to set. As you can see, it says X issued Meter user authorization. So I'm just going to copy this, and I'm going to paste it here. And I will copy this, and I will paste that. So this is one of the ways I can identify myself to the application. And now when I make this call, I get a 200, which is saying that this is my user ID, this is my internal ID, I've got a screen name, and a couple of other information. So just to walk through it, of course, user ID is the ID that I set. Now in Meter.io, there are two kinds of IDs. We have domain IDs and we have internal IDs. Internal IDs are IDs that are generated by the system, and that is what we use for all kinds of internal mapping, right? So these IDs are there only for your reference. In some of the later webinars, we talk about how this can be used to tie along data events, because data events also populate internal IDs, and that's something that you could use for piecing together information. But that's not important right now. The user ID is a domain ID. It's an ID that should reflect your application. So if you have, let's say, an LDAP server or an Active Directory or whatever user directory that you use, and there are identifiers that you're using from there, ideally you would want to map it to some identifier in meta.io, right? So here in this example, I'm just mapping it directly, right? Whatever my application's IDs, I'm just saving it directly. A common pattern that we've seen is we prefix it with something, right? So if I had a user called Mr. Peanut Butter, I would probably do meta colon Mr. Peanut Butter or whatever. So when I'm storing it in meta, maybe I would namespace it by my application or whatever have you. That's entirely up to you. The internal IDs, of course, as we mentioned, is the internal ID used completely for internal purposes. It's not exactly private. You can use it in some advanced APIs. There are advanced usage patterns. Probably a later video would cover that. Then we have user locators. User locators are especially ways to locate a user using certain public globally unique identifiers like email addresses, phone numbers, so on. The screen name is, well, it's kind of like a display presentation thing that you can use to show information to your clients. A screen name is something that we have stopped recommending the usage of. It's kind of a development tool. So for developers especially, when you're just working on an API, you kind of need something that's more recognizable. So you can use a screen name for that. But a little ahead into the video, we'll be talking about entity profiles, and that is ideally what you should be doing for storing this kind of information. Mr. Peanut Butter is not a system user, it's not a synthetic user. Synthetic users are users that don't actually exist but are modeled as users. So sometimes when you delete a user, certain entities they were mapped to would return a user saying with an ID called .deleted. So that's a synthetic user, right? That's not actually a user, but it's the model of the user maps to something synthetic. It maps to a concept. Audit info basically tells you when the user was created, when it was last updated at, and updated at a value of 0 means that the user was never updated, the user is not false, and this identifier essentially repeats this user ID. We will talk about identifiers and how meta.io handles identifiers a little more in detail a little ahead in the video. So as you can see, this is a basic API call. You can make it with a REST client. It's just, there's not much to be done. If you were to make API calls using, say, Node.js, or you want to use your access keys to make an API call, that's kind of a little tricky because there aren't direct values that you could input here. It uses your key and secret to essentially generate a digest, which is a proof of possession of the access key with you. So that's a bit difficult. So ideally, you would probably be using an SDK to make those requests. So yeah, a couple of things I've done for the setup. A few things that have changed is, let me just open up my editor, is I have added an access key. I've added access secret to the .env. This is the token server, by the way. And inside this, I mean, everything's the same. I've just changed users a bit to different values, riding the pop culture train, and yeah, everything else is pretty similar. We've gotten rid of the password for now. We don't need the password, right? So what the app now does is when you log in, it fetches the username from the URL, right? So I have two applications running here. So I've got @Bojack and @Peanut Butter in my documents in my URL bar. And from there, I actually fetch it out using a regex, and that's it. I mean, that's the user that I then use inside app.js. What I do is, after the components mounted, or your React initialization, in some ways, I mean, don't quote me on that. It's not. It's a decent enough concept for now. Is that I make a call to localhost 3000/login/ whatever the logged user is. My method would be post because that's what the backend expects. the token server expects, and then we basically do meta.set user authorization. So this meta object actually comes from index.js, where we have initialized it, and once you set authorization, a lot of things basically kick into gear, right? First of all of your clients are instantiated, they're initialized. So after you set this, you can go ahead and just fetch all the channels. You can subscribe to a payload. So one of the things I've done is I've added a console.log on payload over here, because that will help us inspect what exactly is going on behind the scenes. When new data when new data flows into the system, and then later on we can see how you can actually use that. So when you set user authorization, is it knows that now it has enough information to start processing the pipelines. In the context of Meta SDKs, at least, it would set up a WebSocket for you. So this WebSocket is what is used for transaction of messages. While WebSocket is a full duplex bidirectional channel pipeline, do note that we currently use WebSockets only for downstream. All upstream messages are still sent via HTTP calls. Our next version of our Node SDKs are going to, our WebSocket SDKs are going to support bidirectional transactions for messages, creating channels, whatever. So let's clear this, and one of the first things we want to do is let's just run this application, right? Let's see what happens. Right? So I'll just do a quick refresh on both, and oh, sorry, I did not start my token server, so it's not able to get the token server, right? So now let's reload this page. It gets emitted user authorization, and as you can see, this is a channel that they both are a part of, right? So what happens when I create a new channel? Let's say I create a new channel. Let's create a group chat. I'll add peanut butter, Bojack Horseman here. So as you can see, is while we are not reloading the page, right? I mean, while the participant list doesn't get refreshed because we haven't added any code for that. One of the interesting things that happens is this participation changed event payload and new channel payload. So what are these two things? One of the things is saying that your participation in a channel has changed. Your channel being this new channel that was created. It's V91WP, as you can see over here, and you have PD1NX. This is your pipeline payload ID. So every event that goes out there has a global payload ID. As you note that different payloads would have different IDs though. So I mean, even though it's the same event essentially, the pipeline payload ID is going to be different. It's always unique. It recognizes and identifies a unique delivery attempt of a payload. So what it's saying is that your new status is active. So usually participation changed event payload has something known as an old status and a new status. If old status is missing, it means you didn't have a status in this channel, which means because it didn't exist. So when you get added to a new channel, or a new channel is created with you in it, you or the user gets a participation changed event payload, and you get a new channel payload also. This also contains almost the same data. It says that a new channel has been created, and you got this channel because you were somehow a participant in this, or you were somehow a recipient of this. And we see that both of them have gotten these two payloads. Now a very obvious question would be, why two events? What's the difference? Well, in the case of creation of a new channel, you would always get two events, one of them being new channel payload and a participation changed event payload. But in the case that a channel already existed and you added a new participant, then you would only get a participation changed event payload. You wouldn't get the new channel payload. The new channel payload gets created only when your participation is a part of the operation of creating a new channel itself. So since we don't see this channel yet, I'm just going to refresh this page, and that should fetch both of these channels. And let's see what happens next. So we can just type something, say hey, and these messages are going across. And then that's just basic, messaging that's happening between these two people, right? So an interesting thing here is, let's look at uh, these two payloads, right? So you've got a new message payload, which says that you have a new message, and there is a new message timeline event payload saying that you have a new message timeline event. Now, what are timeline events? Timeline events are things that can be attached to entities that signify certain events that happen on a particular entity. So, in the case of messages, for example, the message being sent is an event, the message being read is an event, the message being delivered is an event, and so on and so forth. Uh, the delivery for a timeline event, so whenever somebody sends out a timeline event, the delivery recipients of the timeline event are exactly the same as the delivery recipient for the message. So every message has a couple of timeline events around it. None of them are mandatory except for send time. So whenever you do send a message, you have to attach a send time payload. So that is something that we can check out in. And again, this is from the getting started application itself, right? So you have a send message and it has method.mted.send time. This is the type that is reserved, and this is the timeline event that must be sent out to signify that this was the time the message was sent out at. Now, you don't expect this to be accurate. This is kind of a guideline as to when the message was sent out as per the claims of the sender or the sender's device. In addition to that, there are other timeline events called server receive time, which are usually not transmitted out, but you can fetch the message and you can get a server receive time, which has the time as per the server's clock as to when it saw the message. The subject is basically who was the user who caused the event. So when you're sending a message, that user is going to be the user who sent the message itself, right? So in the subject over here, you would add meta.me, which in the React SDK gets the current logged in user's user ID. And this is a timeline event that must be sent out with every message. I mean, this is a mandatory field, otherwise the request essentially fails. So if you were to execute this exact same request using, let's say, a REST client, right? So I've got, let's say we'll do a send message. We need a channel, fine. So let's just pick up this channel. This channel looks good. I have a user authorization, and I'll send it as Bojack. And yeah, here you have Bojack saying hello everyone. We'll go through this big block of text in some time, but as you can see, it's sending a message and you get it at both of the places, right? So what all is there in a message that you send out? One of the things is in the API calls, you need to specify a channel ID, you need to specify the sender ID. Now the sender ID basically identifies who sent the message, and that's pretty obvious though. So it's just a field, right? So what happens if I say that the sender ID is Mr. Peanut Butter, right? Do note that all the requests that I'm making are being made by the user at the Bojack, who is identified by this token itself. So changing this doesn't change the identity of the user as the platform sees it, or changing just the sender ID does not change the security parameters or the security boundary of the user. So now if I change the sender ID to @Mr. Peanut Butter and I click on send, I get this error which says required privilege send as other to channel on this is the channel ID basically, but is not granted to user @Bojack. So an interesting thing is the entire meta.io system works on something known as privileges and actions, and there are accessors. So you have something called as an ACL entity. An ACL entity is any entity that you could apply ACL on. So a channel, for example, is an ACL entity, right? So this is the ACL entity that this error message is talking about, and there is a privilege that can be applied on it known as send as other to channel. If any accessor has this privilege, send as other to channel, on this particular channel, then they can send a message while acting as themselves, but with a different sender ID. So what this means is that with this authorization, the platform will always and always see this user as @Bojack. Just changing it somewhere in the body is not going to change the user's impression as meta.io sees it. So at the rate Bojack, if he needs to impersonate Mr. Peanut Butter by checking the sender ID as at the rate Mr. Peanut Butter, he needs to have another privilege sent as other to channel, which by default is not provided. We'll go a bit more detail into privileges and how to modify them, how to grant them to users in some time. Uh, let's get back to this, right? So yeah, let me add another user to the mix, right? So the way the token server is set up is Dex.js. Is set up is whenever you make a login request, you basically a user gets created in Mitter, and if the user already exists, so it, it doesn't really do anything. It ignores it. It moves on. It gets a user token, passes on to the front end for the front end to use. That's as simple as it is, right? So if I were to go back to my panel and I take a list of all the users I have Bojack Horseman, I have Mr. Peanut Butter. I don't really have any other users with me. So what I'll do is I'll copy this and let me go to Diane. Right, as you can see that when I refresh this, and I have Diane over here, and this was the access token that was issued by the server to Diane right about now. So this is Diane's. Yeah, this is Diane's view, and let's see how this happened. Like in a quick bit, right? We could walk over a couple of the SDK concepts also. So what we do is, this is essentially your business logic. This is where you authenticate your user. In the actual token server thing, we do a username and a password matching. But in this case, we are just checking if the user ID matches, and then we are proceeding with it. And you could take a look at that and at the token server as to how it does that. In actual production code, you would probably contact the database, MongoDB, whatever have you. So it checks if the our backend, the token server, recognizes this user or not, and other Diane is actually recognized. So if it's recognized, it makes a call to Mitter using the create user call. The user's client, as you see, we got it using our standard client set. We say mitter.clients.users, and there's also user auth client, which we will use to issue tokens to our users. The entire SDK, almost all the clients and all the API calls that you make on them are promise based, which I guess makes sense because it uses fetch internally or Axios. There are two implementations, and both of them are promise based, and it follows a similar principle. You can compose on them, you can catch any errors that are there. The errors on Mitter.io though follow a certain they kind of follow a certain format that we'll talk about in a bit. So if the create user succeeded, do note that we are considering a collision of the user ID as success too, so that we don't want to throw an error just because the user already existed in Mitter.io, right? That's kind of the principle you would usually follow whenever you're contacting distributed services over the network. So where the user would actually be created in a production application would be when they sign up, when it's bootstrapped, or that's up to you. Usually, while at the time of bootstrap is a common pattern that is followed, but we have seen the usage of this pattern as well, as to you essentially have get or create semantics around users. So if the user was found in your database, then you create the user in the Mitter.io platform. What we are doing here is we are keeping the user ID the same as the user ID that was passed for authentication. We don't want to specify any user locators. This is not a system user, and then we use a screen name. Screen name is a mandatory field, although you can just keep it. It's really good for debugging purposes. When you see all of the data come in and your randomly generated IDs, or even your system IDs would ideally be randomly generated. In this case, they're pretty easy to understand and remember. But you should not be using handles like @name. I mean, internally, I'm very sure you have a different ID as opposed to a display name. So the screen name kind of is helpful while debugging. So it's a good idea to put something meaningful that could give you some information. So yeah, again, if there is an error, if it's a 409, if it's a conflict, this is an HTTP conflict, and the error code specifically says duplicate entity, then this is not an error condition for this. So what we do is, after this is done, we get a user token, and we call login successful response, which doesn't really do much except, so login successful response just sets a status of 200, sets the user ID for the user, and so gives it a user authorization token. This is essentially redundant because your JWT itself contains all of this information, but we're just populating it regardless. Coming back to the error conditions that might happen, right? As one of the things that you could see is one thing is the human readable message. Now, this is again intended for developers. If at any point in time you are propagating this error back to your users in terms of a dialog box, alert box, do not use this message. This is essentially an exception that is thrown. This is not an internationalized message. This is highly susceptible to change. It can change at any point in time without notice. This is only for you as a developer to understand what kind of went wrong. That's it. And this won't be internationalized to your clientele. It will probably be in your subscription language. The error code talks about the specific error code that is there. So the way error codes are set up is at the very top you have your HTTP status code. So we throw 403s whenever a privilege is missing. We throw 400 when a context is missing. So if something just needs an application ID, then it's not a security problem. It's not restricted access, or it's not forbidden. So we won't throw a 401 or a 403. That is when you would get a bad request, because there's just some data that was missing. So you probably get a 400. You get a 401 or a 403. So missing privileges will give you a 403. If you did specify a token which was wrong, for example, right? I mean, if I just like cut out the A, for example, I would get a 400 again. It's just, I don't kind of remember which I did. Yeah. So you would get a bad request because some of the credentials could not be validated at all because your request was actually bad. On the other hand, if you try to, if there was a mismatch in your signature, for example, so if your access key was recognized but the signature was bad, that's when you would get a 401. 403s are like pretty standard and common, and those are the errors that you get for missing privileges. So that basically means your ACL setup is wrong somewhere, or it could be intentional. Though that's just you want to get a 403 if one of your users tries to perform an action they are not authorized to. The instance ID is an ID if you're certainly facing an error and you need support from us. Just write out to support@meter.io and please provide us the instance ID. So we log all of the errors that happen, and then we can help you pinpoint exactly what went wrong. There are a couple of diagnostics we attach. The actor would be which exact accessor was performing this action. This actor is useful for debugging a lot of scenarios, right? Sometimes there are multiple ways of identifying yourself as a user when making an API call. So one of the ways to so sometimes depending on your configuration, it can be quite confusing as to what exactly it resolves to. So the actor will tell you exactly the user it resolves to, which was the acting entity. So the other diagnostics that you see are basically talking about what exactly failed, right? So you try to make a call, an API call, and it failed because some privileges were missing. So this is going to talk to you about exactly what privileges were missing, what the acting entity was, and so on. In the case of this error, for example, when you get a duplicate entity exception, your diagnostics have the ID which caused the collision and what exact entity type was that caused the collision. So yeah, that's pretty much it to begin with. And yeah, this is your standard application, and you've got Diane, and Diane's of course not there in any channel as of now. So I could probably add Diane. Right. So this is one of the things that we were talking about earlier, right? So if you are added to a channel that already existed, you would only get a participation change driven payload. You won't get a new channel payload because a new channel was actually not created. So a new channel payload is extremely indicative of a new channel being created. Again, in this code, we are not consuming these events to populate our React state, so they probably won't show up. But if I reload the page for Diane, I should see this new thing come up, and then got, you know, everyone's on the same page now. So everyone can chat in this, and you have 3 participants. So yeah, let's make this a bit more interesting, right? So what I've done is, let's consume a webhook. Like this, there's a bit of commented piece in the code. Let's just ignore it for now. What we'll do is, we'll create a new webhook. So it's a new post link. It's a /meter webhook, and we'll just do say message received, and that's it. Let's hope our it looks like it restarted, but you know, there's no harm in restarting it once more. We'll restart our Meta server, and now what happens is, what we want to do is, every time a message is sent to this application, anywhere in this application, it could be any channel, wherever it is, right? We wanted to call our backend, right? So one of the ways to do it is to add a webhook. So to add a webhook, I'll go to this tab, the application properties tab. I'll create a new application property. I'll do outflow transactional webhook. So whenever you're creating application properties, right, you can just specify any instance name. So if you have multiple instances, right, if you have multiple webhooks for different events, I mean, that could be a good pattern for you to, you know, segregate your entire code by. You would want to remember what each property stands for. So an instance name is something that is used for your own reference. When you make API calls, you actually use this instance ID to refer to this property. If you want to modify it, if you want to programmatically access properties, then the instance name is an identifier that you use. So this is kind of a reverse tunnel that I've set up to my local host. So basically this meter.io will call back the node server running on my machine. So there are a lot of event subscriptions that you can have, and you can have multiple event subscriptions on a webhook. And this is basically so that if you only wanted to listen to, say, new channel, so you know the fact, I mean, in your application you won't see a new channel being created again and again, but a message on the other hand is something that you would see quite often, right? So to kind of keep the flux low and, you know, selectively only get load on your system as is required, you can have specific event subscriptions. So I just need the new channel message, so I will add this property. So let's see what happens. So Bojack says hey, and yeah. So here, as we can see, in our node server we have message received. That is what we printed, and this is the webhook that we got from the server. So let's just take a quick look at what was sent. So one of the things that we were sent was a global event ID. This is again kind of similar to pipeline payloads, which you receive on WebSockets. You would receive the same thing on FCM if you were using Android. Webhooks and event buses, if you connect via SQS or SNS, you receive an event payload. So it has an event name, the event time. This time is the time at which the event was generated. So if this message happens to be delivered multiple times, which by the way can happen, you have to, your webhook endpoints must be idempotent, and you can enforce idempotency using the fact that your global event ID would be constant across invocations. So if you did have 2 webhooks, then each one of them would have their own unique event ID, but the same webhook would receive the exact same ID if it were to be called multiple times. So what happened is, the event name is an identifier of what the event type was. So this is the meta.mp.channel thread new channel message is the event. This is the kind of payload. So you've got a message ID, and this is essentially, you know, the object that was sent as a message to us, that was sent by Bojack, and it's essentially the React app sending this out. So what can we do with this, right? So there are a couple of interesting things that can be done. What I'm doing is, I want to send out a message of the day whenever a user sends a text saying @MOTD, right? So what I want is, if I say @MOTD, I want a message to be sent out. Let's go back to, yeah. So, you know, I want a message to be sent out to, I want a new message to be like a quote, an inspirational quote or something of that sort, right? So yeah, let's look at this. So I've got an array of quotes that I picked up from the internet. They're public domains, so not a worry there. What we'll do is, Whenever we receive a new message, so let's just quickly walk through the code, right? So we've got, first we extract the event out, right, which is requested body.event. So as you can see, this is the event object that we are trying to request out. And the interesting things that we want is, one of the things that we need is the channel ID. And another thing that we would need is the sender ID, which is also an identifier. Somehow this one doesn't print it, but that's fine. Also we need the text payload, and we'll see what we can do with that, right? So I'm extracting the text payload using event.message.text payload. I'm extracting the channel ID using event.channel.identifier, and the sender. The sender is something that we'll use a bit later. So what we're doing is, if any message starts with MOTD, you can change this to a direct comparison also if you want. I've just chosen to do @MOTD as the beginning of the text. So if the message.index of is @MOTD, then you basically send a message to this channel ID that you extracted, right? So what we're doing is we're sending a message back into the exact same channel that it came from. And here is your sender ID would be .system, right? So a .system is essentially your root user. So whenever you use access keys and access tokens, you are identified as .system. Do know that you could have put anything there. Any other user could have been added here as a sender ID, and that would be fine, because the root user does have the send as other privilege on every single channel. So you can pretty much use every user, but .system is a great way to differentiate between regular users and the application itself sending out messages, be it automated. A very common pattern that we do see with that is users creating a separate users for bots. So it would be like @MOTD bot, and then the MOTD bot would basically send those messages. But yeah, I mean that kind of depends on your usage pattern. This is like a quick way to get started. This is a standard JavaScript snippet of picking a random element from an array. So that's what we're going to do. Then we've got timeline events. Of course, you need to send a timeline event out to a user when you're sending a message. Otherwise, well, you'll get an error saying that it's a bad request. So let's see what happens. Is I've got this channel and I send MOTD. Right. So what happened was we sent an MOTD request. It was sent by Bojack, and since the message was sent to the channel, everybody got it. And this came from our backend itself, right? From our Metro.io host. Sorry, I meant from our token server, our slightly modified token server. Let's make it a bit more interesting, right? So what if I wanted to send out the MOTD only to the people who requested for it, right? So if Bojack asks for an MOTD, only Bojack should get it. So what we'll do is we'll do applied ACLs, and we have a plus applied ACL, and we'll give the read message privilege to the sender. As you can see, we've already extracted the sender over here. So since we've already extracted the sender, this is the sender that we'll use. So basically, whoever sent the message asking for an MOTD is the person to receive it. We save it. We hope that it restarts, and it did. So let's see what happens now. So now, if I send MOTD, that's interesting. Oh, I'm sorry. It's actually it's a spelling mistake. It's plus applied ACLs. So as you can see, only the UI could use a bit of work. So it currently in the getting started page also, this doesn't auto scroll, or it's not like fixed to a viewport right now. So if I send an MOTD, only Bojack gets it. So to make sure that this is on wire, and this is not something that just happens when on the front end where we are like filtering things out. As you can see, Mr. Peanut Butter does not get any of these messages, right? So before this, if I clear this console over here and I send it out, then you get these payloads only and only for Mr. Peanut Butter, and you don't get it for Bojack. Another interesting thing that you might notice is that sometimes you can end up getting multiple deliveries on WebSockets, so you should make sure that you always dedupe your incoming messages, and that goes for any events anywhere, right? So Android apps, for example, could use FCM and WebSockets for delivery, and even though they might be, you could set them up in a staggered pattern where you fall back to WebSockets only if FCM is not present. But just having two sources could uh, could make sure it could result in the fact that you have multiple events being delivered, the same event being delivered multiple times. So this is something that we did walk through in the getting started tutorial, is where we have deduped our messages. Is I think it's in app.js. Yeah, so when we have new message, this is in this line. What we do is, for this given channel ID, we see if at any point in time we have the message ID similar, the same message ID already there for any of the messages, we just return previous state. We don't modify the previous state, we don't persist it. So which is why in this you can see that even though you do have the same message, the same event coming multiple times, we are not actually rendering it twice. We kind of don't modify the state. That is that is what is reflected in the UI. So a few quick words on how ACLs work, right? So let me just create a new thing, right? So in ACLs, let's say you have a message, right? So we just sent out a message for an MOTD, right? We'll just call it this as an MOTD reply message. So what happens is, there are certain operations on this. One of the operations is read message. Right? A read message basically allows you to read a message or not, and then there are two ways to do it. One is when there is forward computation, and then there's reverse. So what happens in forward computation is, if you made an HTTP call to get a message using the message ID, that would be a forward computation, and that's kind of that's straightforward, right? So when if you have the read message privilege, you get back the message, otherwise you get a 403 saying that you have a missing privilege. What happens in reverse is, for all the payloads that are being sent, you need to figure out a way as to what all users have the read privilege, right? So if I send a message, so this was sent to, let's say, a channel, then what's essentially happening is that in the regular case, you just send it out to every participant in the channel, right? That's pretty straightforward. But if there are ACLs on the message, you have to send it out to every single user that has the read privilege on it, and that's what reverse computation does. And reverse computation is in play everywhere when you create a new channel, when a participation change payload happens. So it actually is possible for you to be a participant in a channel but not have a read privilege on the channel. So you would be added as a participant to the channel, but you would never know it. So if you don't have the read channel privilege, and despite being a participant, you actually can be stripped of the read channel privilege, and in that case, even making an HTTP call or waiting on a pipeline, you're never going to get that message, right? You'll never have any idea that you're a part as a participant, but others with a list channel participants can still see you as a participant. So what we're doing here is, we are specifically applying the read message privilege to the sender, like whoever the sender was who sent the message. And because of this, what the system gets this message, and it realizes that it has to send it to everybody who has the read message privilege, which in the case of our message was simply the sender, because we said read message of user as the sender. Right? So what essentially ends up happening is, only Bojack got it. When Bojack asked for an MOTD, only Bojack got it, and when Mr. Peanut Butter asked for an MOTD, only Mr. Peanut Butter got it. And this kind of happens on the wire itself. So if you are not an intended recipient, on no pipeline mechanism, be it FCM, be it WebSockets, you're ever going to get that. So that's kind of how, that's kind of a basic idea of so that's kind of the basic idea of how ACLs work, right? So what happens though when you don't set any ACLs? So we'll just try to send a message again saying hello everyone, and let's look at this block. So what this block is doing is it is applying a couple of ACLs automatically. So there are two sets of ACLs, what we call default and stickies. Stickies is something we'll probably discuss in a later video, but a default ACL is an ACL that is applied for whenever the developer or the call that is being made does not have ACLs on its own. So in this, when we send a message, we just like send out a basic message, and well, everybody seems to have received it. So hello everyone message here and here. But there were no ACLs specified, right? So when there are no ACLs specified, there are like a set of default ACLs that are automatically added, and what the default ACLs, I mean, I guess they're pretty obvious, is that the sender always has read privilege, delete privilege. Every participant in the channel, read-only participants and active participants have a read message privilege, and of course disabled users don't have that privilege. So if you are a disabled user in a channel and you try to fetch messages, you won't have the privilege, and of course the request will fail. Our documentation kind of in the ACLs and advanced permission model talks about how the ACL computation works, and all of the default ACLs are listed. So as you can see, for message, these are the default ACLs that you basically saw right now, which were automatically being added by the system itself. So that is one of the ways to do selected deliveries. In the getting started page, you can see that we have done private replies within the channels. That's also a great example, because that kind of adds ACLs from the client side itself. In this kind of run through, we did it from the backend. So that's kind of a very interesting use case too, to do private replies. A couple of leading chat solutions have come out with that recently. I think WhatsApp was the one which did come out with that. I think yeah. So before we close this, just wanted to walk you through quickly how do identifiers work, right? So I mean, in the code you would see at a lot of places that we have done something like const event ID, not event ID. Let's say we do channel ID is equal to event dot channel ID dot identifier, right? So why this extra identifier, right? Or actually, if you want to get the sender ID, for example, you would get event dot message dot sender ID dot identifier. However, when you created a new message, when you were doing send message, whatever your channel was, here when you specify the sender ID, you just specify the string. So what Meter does internally, it has a concept known as identifiers. An identifier is essentially information about the identity of an element. So it's not just an ID, it's a little more than that, right? The simplest form of the identifier is simply user ID. So this recognizes a user ID with an with a string ID, user ID, right? So an identifier actually is made up of, let's say, an identifier user ID, which would be, well, the domain ID that you set. Do know that in most cases this is optional. You can just skip this, you can not provide it, and meter.io will generate one for you. Then there is an internal ID, which is the UUID that you see that is generated by Meter itself. Then there is an entity type, which would in this case be user. So there is a little bit of more information that is usually encoded as part of an identifiable, which is not, a lot of it is not transferred over the wire. So the entity type, for example, is not transferred over the wire, although there are ways to fetch that also. If you are subscribing to event buses, for example, that is where you get all of this information. So getting back to this case, right? This is quite a curious case as to when do you specify strings and when do you do dot identifiers, right? So a rule of thumb is any request, any response you get from meter.io, any, like whether we get webhooks, you've got REST calls, you've got event buses, whatever, they will always contain every identifier in this format. So if you have a user object, you will have the user ID, which is their actual ID, and then you have an identifier, right? So as you can see, right, it is basically all user fields. and identifier of user ID, right? So I mean, this is a bit more for, like for this is some kind of typing for, I guess I'm using TypeScript notation, but not sure. So either ways, this is essentially assignable to, a type which is simply identifier of user ID. So whenever you're getting any data, whenever you're consuming any data that's coming from meter.io itself, always it will always contain a nested identifier every single time. When you are sending a request, any kind of request, it is entirely up to you. So you could do, if you just, so you add sender ID in your message, right? This could be sender, or you could even send the message as, sorry. Do note that this does not apply for top level identifiers. So for example, a top level identifier of a message is message ID. So a message ID still has to be specified as a string, but sender ID is completely up to you. That you can specify it whichever way you want. So to keep uniformity, what you could do is you could always use dot identifier when doing a request. So even if you do, like, instead of doing a message ID, you can even do message dot identifier if you want to get the message ID, or if you and while making requests, you can always do message ID as a string, and then you can even do sender ID as a string, for example. So that's one of the things that you can do. Yeah. So apart from that, right, a quick brief into what we would be covering up in the upcoming platform, in the upcoming webinar is something a little more to do with how entity profiles work, and how what are the other different kinds of pipeline payloads, right? So we covered new channel, new message, we've covered participation changed. So let's look at so there are a couple more like channel stream data. That's an interesting one. So that is something that we use for introducing and implementing typing indicators. If you're typing something, it will show those three dots, that can be implemented using stream data. We'll cover sending images. Although that's mostly taken care of by the API itself, but we'll walk through the structure of binary images. An interesting thing that you should that one can check out is when you get channels, right? So if you look at the response, there was a so you've got you've got the channel ID, but there's also something known as a channel name. So this meta.cpa.display name here, it's empty. So when you actually created a channel, you had the option of specifying a name, right? So let's say we'll call it Hollywood Friends. The channel ID is randomly generated. By the way, you can override this also the way we override it for all of our users. We said @Bojack, @Diane, and so on. Create a simple group chat with two people. You can actually make it a direct message. A direct message needs two participants, and it will always ensure there are two participants. Well, you got a new channel payload also. I'm just going to refresh this page, and we'll take a look at the channel list that we got. So I think the third one is the one that's interesting, that's the one that we just created. Yeah, so this one, the YQGC3, and its name is Hollywood Friends. So where exactly does this name go, right? It goes into something we known as entity profile. So every entity has something known as a profile. The entities that can have profiles in meta.io or channels and messages. This is a key which kind of identifies what this value stores, right? So it's made up of, it's essentially a key value store where you've got attribute types and you've got values for them, right? It's a simple key value thing. So you can have any keys you want. You can create your own keys. It's just that a specific attribute key or a specific attribute definition has to be created upfront. This is something you could check out in our entity profile API documentation out on apiary. The links for this are also present on docs.meta.io. Of course, whenever you're creating your own attribute keys, do make sure that you don't start it with meta.io.meta. They are reserved, so you won't be able to make a key. You won't be able to make a new key of your own starting with any of those two prefixes. And this is the value that we have as Hollywood friends, right? So the content encoding basically talks about the display is a bit mangled here. So the content type is essentially your MIME type, and your content encoding is if in case this was encoded. So if, for example, you wanted to store the user avatar as a base64 image, then your content encoding would be base64, and your content type would be image slash PNG or whatever as it. So in the upcoming sections, we'll talk about one is of course entity profile. Entity profile is something, you know, that's more user focused data. So like your name, address, email, phone number, so on and so forth. Your bio, description. Then there is something known as entity metadata. Entity metadata is something that is used more for your system to read stuff, right? So let's say you implemented a game using chat, right? I mean, it's like a bot asks you questions and you answer it. For example, for instance, let's take that. So if you do that and you wanted to keep score for that channel, you wanted to keep a leaderboard, who's winning, who's losing, whatever, you could use metadata for that, right? So metadata is queryable. Metadata you can query using equality and range operators. I mean, the support for range operators is being planned in a release quite soon. But this is the data that you're expected to use for machine level information to actually store some programmatic information that you might have about channels. So we'll explore these two concepts, entity metadata and having attributes. We will also be exploring ACLs, advanced ACL usage. We'll see how to modify ACLs, how the modified ACLs reflect into the system, and how you can use, so even a user acting as a client can still modify the ACL. So it's not just you don't have to be able to do it only with access keys and access tokens, right? So you can create channels where no one else is allowed to join, only you can add people, and you can change that rule as an acting user itself. So those are the couple of advanced ACLs that we would talk about. Yeah, so for now, do check out our docs again. We are really excited to see what you build with Meter.io, and in case you have any issues, anything comes up, please make sure you drop an email to support@Meter.io. And when you do that, please make sure you mention the instance ID or your request ID if you happen to be in possession of that. All right, thank you so much, guys. Thank you for the time.